Hello my dear students, today we are in lecture number 42 of chapter 3 current electricity. From today standard 11th lecture has been started. My dear students, those are having doubts or the confusion in differential integration, you can see the video lecture of standard 11th also. Okay, so my dear student, in last class we have concluded with the meter bridge. Yes, it was meter bridge. What we have studied, the meter bridge device, instrument, that is the measuring instrument which used to measure the unknown resistance as well as to measure the potential also. Today we will solve few questions. As I told you, to see the YouTube channel of different school or universities for experiment on meter bridge. I hope you follow that. That would clear your concept much better. Now, my dear student, here we are having a question on meter bridge, and then we'll move for the next topics. So the first question, okay, meter bridge. You know, the meter bridge works on the principle of balanced Wheatstone bridge. You also know the meter bridge works on the method, it is called the null deflection method. Okay, here we are having a meter bridge. It's named meter bridge because the length is 1 meter, either 0 centimeter and 100 centimeter. That's why we used to say it is as meter bridge. The two resistors are connected and the working potential, that is the battery, is connected at the two end. It is A and B, and this is a wire we used to slide a jockey. That's why it is also called a slide wire bridge. This point is connected with a galvanometer which gives the deflection. Suppose at this point we find this galvanometer giving 0 current. This is the IZ, which is as 0. Okay, and this N is called what? Null point. Suppose it is the length X. What will be the length of the rest wire? It is 100 minus X. I hope it is clear to everyone. Now suppose the resistance R and S is connected at 2 points. In meter bridge experiment, this is the terminal plus minus voltage V. In meter bridge experiment, we take one known and then we find another unknown value. So in this question it is given, using this two resistance R and S, we find the balance length. Suppose the first balance length, it is 40 centimeter. Okay, from A we find 40 centimeter. But under certain change, if we apply a 10 ohm resistor with R, remember with R, here the galvanometer is connecting, but with this R, if we connect a resistance of 10 ohm, alright, 10 ohm in series with R, then the new balance, you find that again the galvanometer not showing 0, but after sliding some distance you find again galvanometer shows 0 current, and you find the new balance length, it is 60 centimeter from the same point A. Then question, you have to find the value of R and S. Okay, if you can solve, then try to solve this question. Now look at here. The first one, the ratio of this resistance and the length of this wire also develop a resistance. So R by X 1 will be equals how much? S by this 100 minus X1. Simply you can write this R by S as X1, that is 40 by this will be 60 because total 100, and it is 2 by 3. Let this is as equation. Now the statement, the second statement, this is the first statement we have done. Now the second statement, if we use a resistor in series, then what will be the resistance over here? It is R plus 10 divided by S. It is how much? Now the new balance is 60. So divided it, how will be? How much it will be? It is 40. That is 3 by 2. Now this is the second equation, equation number 2. Now using this 2 equation, you can solve the value of R and S. Okay, my dear student, you will find R as 8 and S will be 12 ohm. 8 ohm, S will be 12 ohm. Okay. Now, I'm giving you a homework. Okay. Let me rub this. Now, student, this is your homework. In this previous question, okay, in this previous question, you find X1, that is the first balance length, okay, at 40 centimeter. All right, from A, which was the same condition in previous question. When you apply R and S, but when you, this is the first statement, that is the first case, and second case, but when you apply a resistor with this R in parallel, how much? 30 ohm, and here the galvanometer is connecting, and then S. So a parallel resistor connected of 30 ohm, then balance length shifted to, then this X2 become 50 centimeter. All right, it becomes 50 centimeter from A, other way it is center. Then you have to find the value of R and S. Find R and S. This is your question of meter base. Okay, student, can you note down? Now the another question will proceed here today. One more question, my dear students, I'm giving you, and then I'll move to the potentiometer, which is very important. Okay, so this is the question. Here one resistor, suppose a wire of resistance R0. All right, a variable resistor tapped at the center. This is the center, remember, this is the center of the resistor. This is the resistor, total resistance is R0. At the center of this resistor, we tapped a variable resistor. At this time, the resistance is R. If there is resistance is R, you tapped, and this is connected by a battery of potential V. When this was not tapped, the potential across this two end was how much? It is V applied. Now when you tapped at the center of this resistor, the question, you have to find the voltage across R. Remember, you have to find the voltage across R. If you write this point as A and this is as B, then you have to find V A B. This is your question. Try to solve this question. This is not very difficult, and I don't think that you need any help to solve this question. Okay, now come to the next topic, which is very important, my dear student. It is potentiometer. Potentiometer. Alternate year, this particular topic touched to make the question, that is the potentiometer. My dear student, remember this is also the portion of experiment class. Okay, in experiment you have to do the experiment which is based on potentiometer. Okay, so here first you should remember this potentiometer. Potentiometer is a electrical sensitive device used as following. What it is used as following. It has many uses, but the following are the very majors. The first one is, this is also, remember, it is electrical measuring device to measure the EMF of a cell. To measure the EMF, okay, of cell. The second that will be mentioned in your NCERT, and this will be also very important, to compare the EMF. To compare the EMF of two cells. And the third one is to find the internal resistance. To find internal resistance. You can see this particular device is so much sensitive so that it can also measure the internal resistance. Okay. Now we will study the construction of this device, then we will be able to study it. So it is the construction. Okay, here we go for the construction of potentiometer. I am representing here the very simple circuit of potentiometer. Look at here. This is the potentiometer wire, say A, B, and on the board this only wire is given, and that's it. Only wire or the setup of wire. Remember, in our lab we use multiple wire potentiometer to increase the length of potentiometer. We will study further. This length of potentiometer actually increases the sensitivity. Okay, the smallest potential can be also measured with the greater length of potentiometer. The potentiometer with the greater length. It is the cell. You have to attach this cell V with the battery eliminator. This V is called driving cell. Remember, this is called driving cell or the driving battery. Okay, now this particular wire is attached on a scale as meter bridge was attached. Okay, it is provided with a scale. So this is the scale, and you need to, this is the internal circuit of potentiometer, nothing else. Now the external circuit, you have to apply here a secondary cell for which you want to do the experiment. So this is the cell and the internal resistance of this cell. It is connected with a galvanometer Z, and this galvanometer is connected with a jockey which gives the null point. So this is the simple construction. This is the battery or the cell of EMF E, internal resistance R, and this is the simple construction of potentiometer, my dear student. Okay, the things that you will use I am going to explain. Then after we'll first study to measure the EMF, then compare the EMF, and then internal resistance of this cell. Okay, now here AB, this point A and this point B, AB, it is the potentiometer wire. Remember, I am explaining here the construction. Remember students, potentiometer wire made up of basically the low resistance material. Now it is the potentiometer wire, this AB. All right, its length will be given of length L. Okay, this one of length L, and resistance R. What is this R? R is the resistance of this wire, AB wire. R is the resistance of this AB wire. Okay, now V is the driving cell, I have written already, and this E is the EMF of cell. E, it is the EMF of secondary cell. The primary cell as driving cell you are using, it might be from the battery emulator you are using. Okay, my dear student. Now G, this G is galvanometer. We have discussed the use of galvanometer, how this works. The zero of galvanometer we use to find at the center. Okay, and the next you can use a resistance with this one also, my dear students. Let me write here. You can use a resistance over here also, R dash. This R dash is the high resistance. Okay, high resistance. This high resistance only provided to just protect this galvanometer. We will study how this high resistance will not affect any experimental observation. Okay, and this length from A to J, what is this J? J is the jockey, metallic pin. We have studied in meter base also. So this J to A to J, this is called the balance length, X. X is balance length, and J is what? Jockey, but this point is called null point. This point is called null point, where you find Ig is 0, where the current through this galvanometer becomes 0. That point will be considered as null point. Remember, potential across this wire is how much? It is the V. This is the VAB. Remember, it is V. That is the potential across the potentiometer. That is the wire of the potentiometer. It is the VAB. Now we will discuss the principle on which this potentiometer actually works. So remember, this driving cell leaves the current, and this current starts flowing. Look at here, when the current will reach at this point, this current will not move to this section. Why? Because when the galvanometer shows the current 0, the total current, it means if it is 0, it means current is not flowing through this circuit, and the total current goes in this circuit. Okay, this is the internal part of the potentiometer, but we are performing the experiment over here. and this is the external part, and this external part not taking any current. Remember, this part is not taking any current from the driving cell. It means the current remain constant. That's why we say it is based on this particular potentiometer based on the principle of constancy of current. We will study in detail what does mean the constancy of current, but we will write the principle constancy of current. Why this constancy of current? I explained here right now. Okay. Now we'll try to study why this is constancy of current, and due to this constancy of current what we get. Okay. So this is your theory. My dear student, here we know that if this wire have the length L, having the length L and the resistance R, then the potential across this one we can write using Ohm's law. V is equals to how much? I times R, and thus V can be also written as I times, for the material having the resistivity rho, we can write rho L by A, where A is the cross-sectional area. Remember, from A to B throughout the cross-sectional area not going to be changed. Okay, cross-sectional area not going to be changed. I here already constant, rho will be constant, same material is used. It means V is directly proportional to what? L, length. Remember, here the proportionality, which one is the constant? At constant, I, rho and A, if we are using as constant, it means V is equals to phi times L, and then why this phi is nothing but the I rho by A, I rho by A, and this phi, which is the proportionality constant, it is called potential gradient. How? You can see from here, phi can be written as V by L. This is called potential gradient. Okay, must remember this is potential gradient, that is the volt per meter. What does it mean by the volt per meter? Suppose you have supplied here the 10 volt as from driving cell, and the length of potentiometer is 10 meter, then its 1 meter length, 1 meter wire will give you 1 volt, another 1 meter will give you 1 volt, another 1 meter 1 volt. So the 10 meter wire is using 10 volt, and for each 1 meter we are having how much? 1 volt. Okay, so this is the potential gradient. This is called the potential gradient. If you find potential gradient, if you trying to find potential gradient, you have to divide this potential across the wire end of the potentiometer wire divided by total length of the potentiometer. But this one is the very important, this one, and this one is the very important. This will help you to find or to correlate the EMF of two cell. Okay, now if you are writing the constancy of current, then you can also write, my dear student, for the principle here, kindly note down. You can continue, because directly constancy of current it is not mentioned in several books, so you will write, you should continue few more words. Constancy of current, that is potential drop across end of potentiometer. Okay, constancy of current, that is, you will write, that is potential drop across end of potentiometer wire. In short, I am writing potentiometer wire is directly proportional to the length. Okay, to the length. Yes, to the length of the wire. How much potential drop across the wire, it is directly proportional to the length. It means across this one the potential will be V, across this one the potential will be how much? It is the potential will be directly proportional to the X. The potential between A and N can be obtained by multiplying this phi with the X. Okay, it means we can write here, I'm writing simply VAN, it will be equals phi times length. Very simple. If you are having the value of phi, by multiplying the X you will get the value. To get the V, that is the total potential, you are multiplying phi with L, that is the total length. So to get the voltage across this one, you have to multiply phi with this one only. Very simple, na? Okay. Now we will understand how this potentiometer work. Okay, my dear student. Before that, we will try to understand the method on which this potentiometer work. Okay, I hope this phi is very much clear to everyone. Take an example, a very simple example. Okay, suppose this is a potentiometer wire and it is connected with a battery of 10 volt of length, suppose 2 meter. Here you are having like this one. Okay, this is the galvanometer, the EMF, and this is the X. What will be the value of phi? So the phi is nothing. Try to find out the potential across this one, and the potential across this one is 10 volt. So this will be 10 by total length is how much? It is 2. So the answer is 5 volt per meter. The very simple. Okay. So in this way you can find out the value of phi. Now we will try to study, we will try to understand the method. To explain that method, I will take a very simple example before writing that method. But this is the method, and what does it call? It is called null deflection method. Null deflection method. With a very simple example, I will explain you. Suppose this is a battery. Here the 5 volt I'm using, okay, and a resistance, and you apply a galvanometer over here. What will happen? This galvanometer will give the deflection. The answer is yes. The current will flow in this direction and galvanometer will deflect in this way. Current is moving in this direction, current is moving in this direction, so the galvanometer will give the deflection. Okay, yes, very good. But if you connect a battery in this way with a galvanometer or resistance, okay, suppose the 5 volt. Now current will move in this direction, and the galvanometer will give the deflection in this way. It will give the deflection in this way. Here it is deflecting in this way. All right, but in both the case, galvanometer shows some deflection. Now another question I am giving you. Suppose if you have connected two battery, this 5 volt resistance, another battery of 5 volt with the galvanometer. Now what will happen? Whether this galvanometer will show deflection if it is 5 volt and this is also 5 volt. This is the resistance, whatever may be the resistance. The answer is yes. But this is not very high resistance. Answer is yes. It will show deflection. How, sir? This will try to leave the current in this way, and this will try to leave the current in this way. But you can see both the current is in same direction, so galvanometer will give the deflection in this direction. But my question, if you will flip this one battery, okay, if you will flip this one battery, what will be the direction of current without changing the value, like this one? if you use 5 volt or resistor and a battery in this way, connecting a galvanometer. Okay, now the question, if it is 5 volt and this is also 5 volt, the plus terminal, now in which direction this galvanometer will show the deflection? What will the answer? And my dear students, the answer will be this galvanometer will not deflect anymore. Now this IZ will be how much? 0. Okay, and in this way, actually this is the proper way we can understand the null deflection method of potentiometer. We will apply the potentiometer wire over here and we'll see there is no deflection in galvanometer. The simple circuit I am drawing here. Next day we will study in very detail about this potentiometer. Look at here. This is a potentiometer wire AB and this is the battery. That's the driving shell V plus minus. Here the 2 cell was there. Okay. This one I am using the same circuit I am making here, and here the galvanometer. Now what will happen? The resistance, if you will connect, remember, if you will connect this particular, after just interchanging one point here and you just remove this one and one point here, can this galvanometer give 0 deflection? Yes, but when it will give 0 deflection? It will give IZ 0 for the voltage if this voltage E and this voltage E are same. You know that the voltage across this wire is V, but for each length the voltage is not V. It is divided in many parts. If this part has the voltage equals to E, only at that point this galvanometer shows the deflection 0. Remember. So in this way, and this is the particular method of potentiometer, which is called the null deflection method. Okay, my dear students, and this particular point is called the balance point that we will use. Okay, students, so in next lecture we'll start this potentiometer in very detail. Okay, thank you very much, student.